Hi everyone, I'm Aswin, a staff engineer at IBM. It's fantastic to be here today, and I would like to thank the program committee for accepting the proposal for this talk and giving a chance to talk. I'm really excited to dive into something we have been intensely focused on for the last one and a half years or so. Um, um, Basically, a new direction for Strimzi that directly tackles one of the persistent real-world challenges when you're running Apache Kafka on Kubernetes. We're calling it stretch clusters, and the idea is simple. Can we make it possible for Kafka brokers and controllers to run across multiple Kubernetes clusters while still managing everything from a single Kafka deployment? Now, you might be thinking, how or why? This talk isn't about a finished feature, but rather a live open proposal within the StreamC project. And we have been receiving incredibly thoughtful feedback from the maintainers and the community members. And I want to extend a huge thanks for all those valuable reviews so far. And what's even more exciting is that we have already built a working proof of concept that we have published in GitHub pages side with detailed documentation on how to set this up for anyone who is interested in trying it out. And I'll try to share the link at the end of this talk. Now, let's start by addressing the most important question of why. Why do we even need to do or even want a stretch clusters? We already have Kafka working on Kubernetes using Strimzi. So why make it more complex by introducing multiple clusters? There are a few big reasons, and they're all grounded in real production challenges. So let me start first with Kubernetes. Kubernetes is powerful, absolutely no doubt about it. It provides incredible resilience and automation for your applications, and Strimzi leverages Kubernetes battle-tested control plane to deliver a robust and reliable Kafka experience within a single cluster. We absolutely rely on Kubernetes for managing our Kafka deployments. However, even with the inherent reliability of Kubernetes, any single bounded environment has its limitation when it comes to extreme availability requirements. But when we talk about enterprise grade mission critical Kafka, we are often looking at scenarios where we need to tolerate risk that extends beyond the boundaries of a single Kubernetes cluster, and that might include things like cloud provider issues or regional outages. Yeah, truly, they're rare, but they do happen and can impact an entire Kubernetes region or availability zone. Or things like major cluster level events such as a large scale cluster updates or reboots, or even unforeseen resource exhaustion impacting an entire Kubernetes cluster. And unfortunately, there can be things like human error that can sometimes impact an entire cluster, even a well-managed one. When such event impacts a single Kubernetes cluster, even if other part of your infrastructure are still healthy elsewhere, the Kafka in that cluster can go offline. And with a stretch cluster, your brokers and controllers are strategically spread across multiple Kubernetes clusters. So even if one cluster become unavailable due to any of the broader concerns we have discussed before, the remaining broker can still maintain quorum and keep Kafka running, which is crucial for application that demands continuous uptime without any client downtime. And this isn't about Kubernetes being unreliable, but it's about pushing the boundaries of Kafka's availability beyond a single operational domain. Now let's move to our second biggest why for stretch cluster, which is seamless migration and modernization. This is a reality for so many organizations today. You might be in the middle of a major digital transformation, perhaps moving your core infrastructure from your own data centers, that's your on-prem setup, into a cloud environment, or maybe you're even shifting from one cloud provider to another to optimize cost or gain some new capabilities in that cloud. These migrations are often huge, complex projects, right? Think about your Kafka cluster in that scenarios. Historically, moving a critical Kafka cluster from one end to another often meant painful, high-risk lift and shift. You'd essentially have to tear down your old cluster, bring up a new one, then migrate your existing applications and data. That often incurs downtime, and to be honest, it's really a huge operational headache. But what if there is a better way? Imagine if you could gracefully extend your existing Kafka cluster into a new environment. You could start add brokers and controller port directly into your new Kubernetes cluster. then perhaps you can do this in a different cloud altogether, while the old ones are still running and serving client traffic. Then over time, you could gradually shift your workloads, your producers and consumers, to these new brokers, and then eventually retire the old ones, all without interrupting your Kafka service. And that's precisely what a stretch cluster enables, right? It acts as a seamless bridge across your infrastructure. It allows you to undertake a massive migration with zero downtime, completely avoiding those high risk lift and shift operations. It's about providing a much safer, more controlled path to modernization. Now, at this point, a very valid question often comes up: Can we already achieve some of this with MirrorMaker 2? And that's a great question, to be honest. MirrorMaker 2 is an incredibly valuable battle-tested tool. Again, no doubt about it. That widely used for replicating topics between distinct Kafka clusters. It excels when your goal is to keep two clusters loosely synchronized. Say, for example, disaster recovery use cases where a little data latency is acceptable, or for specific data locality use cases. For example, you need a copy of data in another region for local analytics or something like that. But let's be absolutely clear that MirrorMaker 2 operates at the application layer. It's about data replication between separate Kafka clusters. And it fundamentally doesn't give you a single unified cluster in a way that stretch clusters do. With MirrorMaker 2, you still have two independent set of care-of controllers, two distinct Kafka namespaces, and your client still need to know which Kafka cluster they are talking to. And operators end up managing two separate deployments, consistently monitoring for replication lag and orchestrating failovers manually, etc., etc. And in contrast, a stretch cluster provides a one logical Kafka cluster transparently spread across the Kubernetes boundaries. For your application, it just looks like one huge Kafka cluster, and your client doesn't have to care where the brokers live. They can connect using the single logical endpoint. And for the Kafka operators, it's about managing a single Kafka custom resource, defining a truly distributed cohesive Kafka cluster. And this kind of eliminates the complexities of separate deployments, manual topic replication, lag monitoring, and cumbersome failover that comes with MirrorMaker 2 for this type of a problem. So while MirrorMaker 2 is an excellent tool for specific patterns, especially when you truly want decoupled clusters, then MirrorMaker 2 is the go-to option. But if you want, if you need is seamless migration, zero downtime migration, or truly shared high availability across failure domains with synchronous replication, then a stretch cluster is far more integrated and powerful solution. It addresses a different class of problems altogether. And this leads us directly to our third key justification, which is multi-cloud and hybrid deployments. So in today's complex enterprise landscape, it's increasingly common that organizations to operate across diverse environments. For example, for regulations and data sovereignty or laws, or even strategic business decisions might dictate that certain Kafka workloads remain on premises, perhaps in your secure data centers, or for compliance and performance reasons. Yet other part of your business needs something like agility, elasticity, and extensive managed service offered by a public cloud. So how do you reconcile these needs? A traditional single Kafka cluster forces a choice, but a stretch cluster fundamentally changes this. It allows Kafka to operate as a single unified entity across these disparate environments, seamlessly bridging your on-premises infrastructure with your cloud deployments, or even connecting Kafka across multiple cloud providers. And this unlocks a level of architectural flexibility and operational agility that traditional single cluster model just can't provide. All right. Okay. Now let's talk about why Kubernetes is still the right place for Kafka. Now, before we dive deeper, it's worth quickly stating why we are even doing this in Kubernetes. Kafka traditionally has been a very heavy stateful system. But with cloud native shift, we are seeing more and more teams choosing to run Kafka on Kubernetes, and that makes a lot of sense, right? You get the consistency, the same APIs, the same tooling, the same automation, whether you're on premises or cloud. And Kubernetes gives you self-healing, auto-scaling, and rolling updates out of the box. And when you add Strimzi, managing Kafka become declarative, version controlled, and much easier to integrate with your existing CI/CD pipelines. And Kubernetes becomes your unified orchestration platform, and Strimzi make Kafka feel native to that world. Now, now that we have talked about why stretch clusters are important, now let's get into the how. This is where we talk about technical pieces that makes this vision a reality. Our proposal is built around a few key steps that leverages existing Kubernetes concepts. The fundamental idea is to make Kubernetes aware of multiple clusters, multiple Kubernetes cluster, and then teach Strimzi how to manage Kafka across them. So the first crucial step is to get all your Kafka clusters talking to each other under their place in a larger cluster set. So this is where Kubernetes multi-cluster services, or MCS, comes into play. Think of MCS as a standard way for services in one Kubernetes cluster to be discovered and accessed by pods in another cluster, even if they are in different locations. So it's a key part of how we enable stretch cluster communication, at least for the prototyping phase. And every Kubernetes cluster that is part of our stretch cluster setup needs a unique identifier like a cluster ID. There's a standard Kubernetes enhancement proposal, KEP 2149, which is something like KEEP for Kafka, that defines an abort API for this, giving us properties like cluster.clusterset.k8.io for unique cluster ID, and clusterset.k8.io for overall group of clusters. Some MCS implementation like AWS Cloud Map uses something called cluster property resource to set up these IDs. Others like Submariner or Cilium have their own ways, but the goal is the same: to give each cluster a clear identity within a larger set. And as users, you'd refer to your choose an MCS solution documentation for how to set this up. The cluster ID thing which I've mentioned is super important, because the Strimzi cluster operator will use it to build the special Kafka configuration for advertised listeners and controller quorum voters, which allow Kafka to know where all its brokers and controllers are, even across cluster boundaries. Now, since we talked about MCS, it's worth briefly explaining two powerful technologies often used for cross-cluster communication, and that's Submariner and Cilium. So imagine Submariner as a kind of a virtual cable that connects your Kubernetes clusters together. It creates secure IP tunnels between your clusters, allowing ports in one cluster to directly reach ports in another, as if they were all in the same network. It's fantastic for bridging network across different cloud providers or on-premises data centers and so on. So with Submariner, once the network is connected, the standard Kubernetes service API can be extended to discover services across cluster. Now, talking about Cilium. Cilium is, again, another powerful networking and security solution for Kubernetes that uses something called eBPF technology. While it's great for single cluster networking and security policies, Cilium also has strong multi-cluster capabilities. It can create a unified network across cluster, managing routing, load balancing, network policy seamlessly. Its multi-cluster setup often involve a shared control plane or specific configuration that allow port to communicate across cluster boundaries with high performance and security. So now, how stretch clusters work with Submariner and Cilium? With Submariner or Cilium providing the underlying cross-cluster networking, stretch cluster design focuses on how Strimzi leverages that connectivity. So Submariner and Cilium provides a network layer that connects Kubernetes cluster together, and Submariner set up secure tunnel and service discovery. So Strimzi can use the DNS names to configure Kafka's advertised listeners and control quorum voters. And similarly, Cilium does something pretty similar by creating a shared network across clusters, routing traffic based on those DNS names. So in both cases, for Submariner and Cilium, these tools make it possible for Strimzi to run Kafka smoothly across multiple Kubernetes cluster, as if they were kind of a single system. Now, the step 2 is to deploy the cluster operator. So we need Strimzi cluster operator running in each Kubernetes clusters that will host the Kafka components. The operator in your central Kubernetes cluster, where you will define the Kafka and Kafka node pool custom resources, need to know about all the other cluster. We provide it with their unique cluster ID, their Kubernetes API server URLs, and the necessary credentials, the kube configs, in the form of a secret to talk to them. So this information is passed simply as an environment variable in the central cluster operator deployment, and makes it easy to configure. Now, the third step is to define your stretch cluster with custom resources. This is where the user experience comes in. I mean, to be honest, user has to configure the environment variables as well, but this is where the user interacts with the custom resources to deploy a stretch clusters. So how users tell Strimzi that they want a stretch clusters. So to enable stretch cluster functionality, you add a symbol annotation to your Kafka custom resource, which looks like strimzi.io enable stretch cluster to true, and this clearly tells Strimzi that what your intention is. So Strimzi is smart enough; it only activates the stretch mode if the central operator is also correctly configured with the remote cluster credentials. So if anything is missing or misconfigured, it will fail loudly and clearly, preventing unintended deployments. And the good news is this approach means no changes are needed to the Kafka custom resource definition itself, and you can even run both a stretch and a non-stretch Kafka cluster with the same cluster operator instance. Now, talking about the Kafka node pool, the Kafka node pool CR stays in the central cluster, but we add a new annotation, something like strimzi.io stretch cluster alias, and this tells the central operator which Kubernetes cluster the specific node pool and all its associated components should be deployed to. For example, strimzi.io stretch cluster alias colon cluster 3 would send the node pool to a cluster identified as cluster 3. The operator then creates all the necessary Kubernetes resources for that node pool, the Strimzi port set, services, config map secrets, what else, persistent volume claim for the storage, and so on, directly in that specified remote cluster. And the Kafka node pool itself, however, remains in your central control plane or the central Kubernetes cluster. And this design ensures that your entire stretch cluster identification resides in a single place, and that is your central Kubernetes cluster, making management much simpler. Now let's look at how Strimzi operator adapts for a stretch cluster. In a stretch setup, the central operator is responsible for creating all the Kubernetes resources, as I mentioned before, like SPS, services, service accounts, config maps, secrets, PVCs, and so on. Not just for the central cluster, but also for the remote clusters, based on the annotations in the Kafka node pool. And this means the central operator acts as a single source of truth and orchestration point, and the remote operators then picks up and reconcile only the Strimzi ports resources destined for their specific clusters. And we have some active conversations around this, whether the remote cluster should only reconcile SPS or not. But yeah, that's an open discussion out there in the proposal. And for Kafka brokers and controllers to communicate across cluster, their network configurations need to be adjusted. In a single cluster, the Kafka ports uses the internal Kubernetes DNS name, but for stretch clusters, the advertised listeners and the controller quorum voters property need to use the special multi-cluster DNS names provided by the respective MCS implementation. And the Kubernetes MCS standard specifically, if I remember correctly, it is KEP 1645 that defines a standard format. So our operator sets the Kafka listener to something like broker port name dot stretch cluster alias, then the broker service name followed by namespace.svc.clusterset.local. This svc.clusterset.local suffix is vital because it tells DNS resolver that this is a multi-cluster service, allowing them to correctly route traffic across Kubernetes cluster. And this change is only applied when stretch cluster mode is enabled. A regular single cluster deployment remains unchanged. Now, talking about security is paramount. When Kafka brokers and controllers talk across Kubernetes cluster, they should do so securely over TLS. And to make sure that this works flawlessly, especially with with things like hostname verification, the operator generates a TLS certificate with additional subject alternative names, entries in the broker or controller ports. And these new SANs include the .cluster set .local based DNS names, and this ensure that broker running in cluster A can securely verify the identity of a broker running in cluster B when they communicate without manual certificate gymnastics for the user. And finally, the status of the Kafka custom resource will be updated to reflect the multi-cluster nature. For external listeners, you will see bootstrap addresses for each kube cluster that's involved in the stretch cluster setup, which will give an overview of your distributed Kafka cluster. And the Kafka node pool status will also indicate if a target cluster become unavailable, providing an immediate fallback to any issues. This is a high-level architecture of stretch cluster. I'm not going to go deep into this due to the time constraint, but I believe I've covered most of it already. Now, I guess I have time, so I'll try to show a quick demo. So I've got 3 Kubernetes cluster here. STR4, STR5, and STR6. So this stands for stretch. Now I have installed and set up Submariner in all the 3 Kubernetes cluster. It's pretty simple to do. I'll quickly run some commands to verify that the installation is fine. So I'm running a subctl show connection, which will show the connections to the other cluster. For example, I'm running it from the central cluster. You can see that STR5 and STR6 are connected. So this is remote cluster 1 and this is remote cluster 2, and STR4 is the central cluster in this case. Now I'll repeat the same for other 2 clusters as well. Hopefully it will be pretty quick. So I'm checking this for the last one. So now the Submariner clusters are connected. Now I'll run the subctl show subctl diagnose firewall intercluster. This is basically this is checking the intra-cluster VXLAN firewall configuration. Basically means that it is not, Submariner is not blocked by any firewall settings. So let me run this for the central cluster, and I'll repeat for the other 2 clusters as well pretty quickly. Sorry, I've done something wrong there. Let's do this let's copy this and repeat it for the other clusters. Once we get a tick mark here, that means that the setup is correct. The Submariner is correctly installed, and it will be able to route traffic across clusters. So yeah, it looks correct. So the Submariner setup is okay. Now I'll go to my central cluster. I'll show the install operator. I'm using a custom image. As I mentioned before, this is not an official Strimzi feature yet. So I'll just show the custom image that I'm using. I'm using this image. I think it's there in the doc or GitHub doc, which I've mentioned before. So now going to the environment variable section, this is the envar that I was talking about. So this is the endpoint of the remote clusters and the secret to connect to them. I'll quickly show you by applying the CRs. Before that, I'll go to a different tab. You can see I've got watches for the 3 Kubernetes cluster 1, 2, and 3, and I'm just watching for the remote resource creations as well, like SPS and SAs and all those things which I've mentioned. So hopefully it will work. I haven't tried it for a long time. Sorry, I've copied a wrong thing. So let me copy this again. Apply. All these things are already specified here. So please feel free to check this out if you want to learn more about this. Now, once these things are applied, so this is applied, hopefully you'll be able to see, the resources getting created in the remote clusters. I think this is the central cluster. Yeah, the kube config is the central cluster. This is for stretch cluster 1. This is for the remote cluster 2. And once that's almost done, you can see the ports start coming in. So this is for the stretch cluster 1. So this is the remote cluster 1. And hopefully it will bring ports everywhere. Luckily, the setup is working. I'm pretty sure that it works. It worked before. So once the port are up and running, I'll run 2 more comments. I'm not sure how much time is remaining, but let's see. Yeah, I guess all ports in all the clusters are up and running now. So I will go to I'll take one of the ports. I'll just exec into one of the ports in the central cluster. I mean, you can exec into any of the port, that doesn't matter. But if I'm doing it in the central cluster, I don't want to provide a kube config. So that's why OCRS is in proper too. Then if I describe do the quorum listing, it should now have details of all the remote clusters. So you can see that the current voters are these and current observers are these. And similarly, if I am listing the replication status, I mean, it's pretty much similar. It will list all the all the available brokers and controllers and see who are the brokers, who are the leader, and who are the followers, etc., etc. Now, going back, what else is remaining? Yeah, as I mentioned, now before I wrap up, it's really important to emphasize the fact that uh, what I've shown you just now, and the proposal we have discussed, right, is a live evolving prototype. It's not finalized yet. There is a lot of comments from the community. We are currently working on this actively. Yeah, this is not a finished feature that's set in stone. We have built a working POC to demonstrate the feasibility. And that's what you just seen a moment before. And the proposal is still actively being refined with the feedback from the Strimzi maintainers and with the wider community. And what this means that the XAD architecture, the design choice, and even the specific implementation details might change in future as we continue to iterate, evolve, learn, and incorporate the feedbacks. And our goal is to deliver the best possible solution for running a highly available and flexible Apache Kafka on Kubernetes or for across multiple clusters. And we encourage you to check out the POC, provide your feedback, and join us on this journey. Also, if anyone is interested in the proposal, it is open in Strimzi, ID 129. That's it. Let me stop sharing. If Paolo can stop, that would be nice.
Great. Thank you very much, Aswin. So, yeah, as Aswin mentioned, there is a proposal for that. So it will be great to have your feedback if you are interested to jump into discussion about the stretch cluster thing. So we have just a couple of minutes. Let's see if we will be able to answer at least a couple of questions. We have actually 3 questions from Fred. So the first one is, in maintenance or unplanned issues, do you migrate brokers controllers between sites when nodes are down?
Sorry, can I see the question, Paolo?
So if in maintenance mode, when you have some maintenance to do, I guess, are you going to migrate brokers or controllers between the sites when nodes are down? So migrating the brokers and controllers across the several Kubernetes clusters that you have, I guess, when some nodes are down in the Kubernetes clusters.
No, not really. When maintenance is happening, ideally it should be possible. I think Strimzi has something called a drain cleaner, right? So which can be used when a maintenance is happening. So this is mostly for migrating your Kafka cluster from one cloud provider to another, or from your on-prem setup to the cloud or something like that. And I've not really thought about migrating your. It might be possible, really. I don't think there is anything stopping from doing that, but we'll have to think about it in a bit more depth.
Okay, so the next one, how do you address transient network and network connectivity issues or network partitions?
I'm not clear with the question. What does that mean? Is the question asking about what happens if the network connectivity with the Kubernetes cluster is broken for some reason?
Yeah, I guess if there is any specific handling about that, if it's happening.
No, the expectation is that these networking technologies are proven. For example, Cilium is G8 or CNCF graduated projects. Submariner is also evolving. So if there is any specific networking failure that happens, then The idea is that the remaining the brokers and controllers, which is already not affected by the network failure, right? They can continue the Kafka quorum and continue serving clients. But if the network is completely down, then no one can help. I mean, it's the same case with the single Kubernetes clusters as well, right?
And yeah, I guess slightly related to the previous question, it was asking, have you found there to be a physical limit to the distance you can reliably maintain quorum for the cluster, such that you don't often have blips in stability? For example, can you have brokers in Europe, US, APAC, or should you keep things within the same continent due to latency?
Yeah, I mean, as we all know that Kafka is sensitive to latency, so it will be challenging to spread our brokers and controllers across distinct continents. Why? Because it all depends on the connectivity, and Kafka is inherently sensitive to latency. So we are working towards finding a maximum acceptable latency, the maximum acceptable level of tolerance. But that's yet to be experimented, to be honest. Asking about whether we can spread brokers and controllers across continents, I'm not pretty sure whether Kafka supports this. It should be something that should happen to the in the Kafka itself, not in Strimzi, if I'm correct.
Yeah. Okay, so yeah, thank you. We are running out of time, and thank you very much, Aswin, for joining and for presenting this. Again, there is a proposal for the people who are interested to know more about the stretch cluster ideas. It's in the Strimzi proposal repo, so please provide your feedback and see how much this is going to be useful to the community or not.